All right, let's go ahead and get the ball rolling. So, for those of you who didn't meet me yesterday, my name is Chris Granger. I'm a program manager here with the Visual Studio platform. And this is kind of our round 2 of the editor series of talks, right? And we're going to be talking a little bit today, building on what we learned yesterday about integrating languages into Visual Studio. And so the first thing I actually want to talk a little bit about is the managed language service and our old COM APIs. And the reason why I want to talk about these a little bit is because I know a number of people who are working against Visual Studio 2008, who already have language integrations, probably built against, or may have built against the managed language service, which is basically a part of, for those of you who don't know, is part of the managed package framework that makes it easier to write languages against the old APIs. And the reason I bring this up is because we built an adaptive layer on top of the editor that we refer to as the editor shims. And what that adaptive layer does is make sure that those old COM APIs still work so that you guys don't have a really difficult path of trying to get your bits working on Visual Studio 2010 right off the bat. And so what we hope you'll find, and what we found internally, is that for the most part, getting your bits working is a matter of switching some references and rebuilding against Dev 10. We have a couple of documents out there right now that explain a little bit about how to do this. And we know that there are a couple of places in the COM APIs where you do have to do a little bit of shifting around. And we're going to get some documents out about that coming up soon. So if you are using the managed language service, if you are using the COM APIs, our hope is they should just work. But we're not here to talk about the old world, right? We're here to talk about the new APIs. We're here to talk about what everything looks like in the new editor and how you get a language inside of it. And so we have to decide, first off, right off the bat, well, we want a language. So let's pick a scenario here. Let's pick a language and actually try and integrate it in this little talk. It'll be interesting, right? And the language I picked was something called Ook. It's an esoteric language. It only has 3 operators in it. Ook period, Ook exclamation point, and Ook question mark. It is the language of orangutans. But when we think about trying to get a language inside of Visual Studio, right, at least in 2008, what we were thinking about was trying to integrate this first-class object and give it into Visual Studio, this thing called a language service, right? Well, in Dev 10, that has shifted around a little bit. There's been a slight conceptual shift in thinking here. Because instead of thinking about trying to get a language inside of Visual Studio, what we're trying to actually do is add our own content type to Visual Studio. Now, that may not seem like a big difference, but conceptually it is quite a big difference. And the way I want you to think about this is that content type is a bucket. So instead of giving Visual Studio this object and everything works off of it, instead, by creating a content type, what you're doing is creating a bucket to put extensions inside of. And so your language functionality is basically built as extensions that fit in your bucket for your language. And so for our example with Ook, right, or excuse me, I mentioned this a little bit yesterday, that content type, while technically a graph, right, is actually while a graph can be thought of as a hierarchy. And up at the top of this is a content type called any, and that will literally reference every instance of the editor that exists. And then you get more specialized content types coming down from that, things like text, and then you have a specialization of text called code, right, and then C#, basic. So what we need to do is get ourselves added to this hierarchy, right? So Ook is code. It is a coding language, right? And so what we're going to do is export out something called a content type definition. Now, to get yourself inside of Visual Studio, you do the same thing you do for any other type of extension, right? We're using the managed extensibility framework here. We're using those attributes that we talked about yesterday, export. And so we're exporting out our content type. And you can see we give it a name of Ook, right? Because our content type is going to be Ook. And then we tell it that the base definition, basically its parent, is going to be code, right? So we're going to derive from code. And the other little bit of code you see here is what gets us our file extension mapping, right? So if I open up a .ook file, I expect my content type to be Ook for that editor instance. And so that's what this other line does. And so conceptually what we've done, right, is simply added a leaf node onto our hierarchy here so that we now have our OOC content type. And what that means is anyone can now start filling up that bucket with functionality. Anyone can start writing extensions against your language, if you will. So content type gets your foot in the door. Basically, it's the very first step you need to take. If you want a language inside of Visual Studio, you need to go ahead and create this. Now, what's interesting, of course, is if you're already, if you want to work against the language that we've already added, right? So C#, you want to enhance it in some way. That content type bucket is already there. And so you just write extensions whose content type association is C# or whatever the case may be there. But we're talking about how do we get a language right inside of that bucket now. Now we need to talk about what exactly do these extensions look like. And in order to do that, we need to talk about, well, what does a language integration inside of Visual Studio even mean, right? So those of you who integrated against 2008 know that this basically is the list. This is the list of all the things that a language service tended to provide. Things like syntax highlighting, right? So at the most basic level, a language service needs to provide syntax coloring. Then you have things like outlining, being able to collapse text if you have a nested language, right? You have things that probably one of the most powerful things you can provide is the IntelliSense stack. So things like quick info, smart tags, parameter help, statement completion is the most popular. And you also have brace matching, the ability to format. And so another one that's big for us, right, is this notion that you can have errors inside of the editor, that you have a compiler running against the code that you're working on, and it's telling you might be doing something wrong. And then navigation bars. Now looking at this list, it's a relatively short list. Probably none of this is a surprise to you. But in a lot of ways, it's kind of difficult to understand how this list relates to that list, right? This is the list of all of our APIs. And it seems like what we've done is taken this idea of a language, right? And we broke it into a million pieces. We broke it into all of these pieces. Each part of it is now sort of its own thing. And so to understand maybe why we did that, I want to talk a little bit about some of the benefits we actually get out of this, right? And so the first one is this notion of granularity. So before it was really hard to provide something small in terms of a language, right? But because we have broken all of these things apart, and because there's this thing called content type, right? You're able to provide bits of functionality on their own. So if you wanted to provide new completion sets, for example, for C#, you can actually do that. Just that and nothing else. And so you get this notion of I can be very granular in my approach to creating language or to creating functionality on top of a language. And really tightly coupled with that is the notion that you can be extremely incremental about your development of a language now. It's not an all or nothing scenario. I can basically create a syntax coloring for our OOC language, and then I can be done with it. But that doesn't mean that that language can't continue to get better. So I finish my syntax coloring, I put it up on the Visual Studio Gallery, someone downloads it, they like to write in OOC, and so they start writing statement completion for OOC, or they start writing quick info for OOC. Since it's just a bucket, they have the ability to put extensions inside of it themselves, right? And so there's this notion that you don't actually have to do it all anymore, which is kind of a great idea when you think about it, right? 2 heads is better than 1, well then 10,000 potential heads has to be better than that. Oh, and so one of the things I didn't really mention there was also they don't have to have access to your code, right? So you could do this before, but people would need access to your implementations. And since these things are broken up into pieces, since they are so incremental, they don't need that. And that's kind of where this notion of you don't have to do it all comes from, right? But we're not here to talk about all of this in concept, all of this in theory. We're here to talk about how we build this list out, right? Or at least parts of it. We're not going to get to all of it, but we're going to get to parts of it. And so let's take it from the top. Now, yesterday I showed a line of code that looked just like this, right? We talked a little bit about syntax highlighting, and we said that syntax highlighting in the new editor is something called classification. And basically, you can think of classification as breaking up some grouping of text into spans that we then say that span or that range of text has some form of classification type. So if we think about that in terms of that same line again, right? The if is a keyword. The x, y, and z are variables, but we describe them as user types in terms of classification, right? And then we have a comment, right? Its classification type, or the comment would be its classification type. I also mentioned the fact that classification is essentially a more specialized form of tagging, right? So tagging is this very general purpose mechanism where you're able to label some spans inside of, or some spans with extra data, essentially. So it's probably no surprise that under the covers, classifications are themselves actually tags. And the reason I bring this up is because the classifier that we're about to look at, we're not going to write it, but we're going to look at a bunch of code today. And it's not necessarily, I want to point out, it's not necessary that you understand every line of the code, but it's more important that you understand the concepts about it. And so I'm going to be very deliberate about that. The reason I bring this notion of tags up is because instead of implementing our classifier as an I classifier like we did yesterday, today we're going to implement it as a tagger. So let's take a look at what that is. So remember, I said that the OOC language, right, has only 3 operators, OOC exclamation, OOC period. And so this is the test file we're going to work against. Now, I kind of harped a bit yesterday about this notion of using taggers to provide data, right? This notion that if you start out with the data, other people can then use it. And so before we get to our classifier, what we're going to take a minute to look at is this OOC token tag, tagger. And so the idea here, right, is that if I provide the ability for other people and myself to know exactly what token they're looking at any one point in time based on its type, that means that they don't have to try and do that work over again. And this will make my life much easier. As you'll see, we'll go along, we'll use this tagger all over the place. And so if you remember, with tagging, there's one method you really need to be worried about, right? This getTags method. And you're given a collection of spans with this, and you're expected to return back basically a list of what's called a tag span. And it's essentially a tuple that links together a span and a tag. And so this looks a lot like our tagger did yesterday. It's a little bit more complicated because what you see we're doing here, and this is a very common pattern, this is actually how C# works internally, is that we're looking at certainly the spans that we were given, but we're mapping those back to a line so that we can actually parse the whole line. And then what we're going to do then, right after that, is go ahead, split the line. So we're just doing regular tokenizing here, nothing crazy. We're splitting the line on space because everything in OOC is separated by a space. Checking to make sure that the token is a valid token. So if you see up here, I've defined all of our potential token types, right? Just exclamation period and question mark right here. And then because we looked at the line, right, and not necessarily the spans we were given, you see this. Now, this is the one thing that really makes this different than what we did yesterday. So we're looking at a line, but the thing I may have been asked about probably wasn't necessarily that entire line. It might be a part of that line. It could be the whole file, right? And so what I need to do is make sure that the token that I'm going to return back to you, right, this tag that I'm going to return back to you, is actually in that span, or at least intersects with the span you asked for. So that's all we had to do. Right here, you see, that's all we had to do to create this tokenized version of our tags, right? And then this makes our classifier nice and easy. So I mentioned, right, that instead of exporting out an iClassifier provider here, we're actually going to export out a tagger. And we are associating it to our content type. Now, this is something kind of interesting. So this is the code that we saw before where we were creating our content type of OOC, right? You can see you can actually export that out inside of something else that you're exporting, even though it's going to be directly associated to the content type that you're giving there. And just like yesterday, right, we're going to get our iBuffer tag aggregator factory service so that we can get our tag aggregator for our token tags that we've created. And so let's look at how this tagger is put together here, right? So we're getting If you remember yesterday, we defined to do as this orange, or having an orange background, right? And that's because we said that that it had the classification type of to do, and we associated a format with that. Well, in here, what we're doing is go ahead and getting classification types for each one of our operator types, right? And then we write our tagger. So here we are in our getTags method. And you can see it's incredibly simple, right? We did all the hard work already. We already know where the tokens are. And so what happens here is we go ahead, we iterate through the tags, right? We get a tag span for each one of them. And then we just basically convert those into classification tags. Now, this is a fairly common pattern. This notion of creating, we do this all throughout our code. This notion of creating sort of a general purpose tagger, right, and then creating taggers on top of that that might just convert those into another form of tag, in this case, classification tags. And so let's see this run against our little test file. We'll build it here. Run it using the wonders of our SDK, right? Bring it up in an experimental instance. Let's open up that test.ook file, and we should see that we should get syntax highlighting here in a second. Because we've created a tagger that gives out classification types, right? And so you can see each one of these is highlighted, or syntax highlighted as we expect, and it's happening in real time, right? So I type an exclamation point, it turns purple, type a period, it turns green, so on and so forth. So you can see our taggers, both of our taggers are working, right? And that was a very small amount of code just to get this syntax highlighted nice and easily. So let's go back to our deck here for a second. So you saw tagging make all of this work, right? So that's the only thing we built there, was two different taggers. Tagging, interestingly enough, also, because it is such a general mechanism, applies to a number of other things that you might want for a language service, right? So the notion of errors. When you think about errors conceptually, all it is basically saying that a span of text inside of the editor is wrong, that you've somehow made a mistake, right? And so what you would do to add errors to your language is basically write an I tagger of squiggle tag, right? So based on the name comes from the fact that we draw squiggles underneath them. And what we do is we have this little adornment manager that goes in, looks for all of these tags, and that's what actually draws the squiggle underneath them, right? So we are looking for these tags ourselves. We're consuming the squiggle tags. Another thing that you can do as tagging is outlining. So again, thinking about this purely in concept, right? When you say something is collapsible, all you're basically saying is this range can somehow be shrunk down into something else, can be turned down into something else, right? And so what you're doing is saying, or what you would do is create an I tagger for I outlining region tags, and then anything that's tagged as that, we go through and say, okay, this is something we can collapse. Our margin will then give you the plus or minus, right, that you would expect, and you get all of that functionality for free. So these are the things that you can actually create using nothing but the very simple mechanism of tagging, right? So you can get syntax highlighting, the errors, and outlining. But those are not necessarily the most interesting things, right? Those seem kind of basic. What we're interested in, probably, is the slightly more advanced case of IntelliSense, right? This is what helps us really get better at coding. Not necessarily get better, but be more efficient at coding, right? And one of the things I want to mention here is that when we talk about IntelliSense in terms of the editor, a lot of people think of it as statement completion. They use those words synonymously. But when we talk about IntelliSense, we actually mean this stack of things right here. We're talking about quick info. We're talking about smart tags. Statement completion is certainly in there, but we're also talking about parameter help. And so this is what we consider IntelliSense. And the part of the reason why these are grouped together is certainly they're very code-focused, right? So there's this notion that they somehow have a bit more understanding of the code itself. But they also follow the same architecture. Now, model view controller is probably nothing new to most of the people in this room, I would imagine. But everyone seems to have their own flavor of it, their own idea of exactly how this plays out. And I want to talk a bit about what this looks like for IntelliSense, right? And so the high-level picture of what this is looks like this. So the green box, right, is our model, is our data. We call it a source. Now, each element in that list, right, so quick info, smart tags, and so on, has each one of these elements here. And so you could imagine the source for statement completion, right, being the list of potential completions. Then we have the controller, and we'll talk a little bit about exactly what the controller does for us, but you can think of it basically as something that starts the middle object, a session. Now, sessions are basically just the state or the context of IntelliSense at any one point in time. And we're going to drill into all of these here in a second. But I wanted to give you this high-level overview. And the last thing, right, is this presenter. It's just the view. It's the UI that we present to you when you're dealing with IntelliSense. And so let's start off with the session here, and then let's go into exactly what that means. So I said it was the context, right? It's the state of IntelliSense at a point in time. And I said, or I didn't really mention this, so when we talk about statement completion, let's think about what the state is here, right? So if I type a period inside of, or working in a C# file, I've basically started a session. What I've done is I've said, we're now going to deal with IntelliSense, right? In this case, completion. And so that session is going to stay around. Its lifetime is until that UI basically goes away. That's the easiest way to think about it, right? So when I say we're no longer trying to complete something, we go ahead and dismiss the session. The trigger is very important with this notion of sessions because, or excuse me, the controller is very important with this notion of sessions because it's the triggerer of these sessions to begin with. So when we think again about C# and we press a period, right, the controller is going to go, oh, you now have pressed a period because I was listening to what you were typing, right? And I know that I need to now start an IntelliSense session. I need to create a session and go ahead and start it up. The same goes with if I press escape, for example, right? The controller is going to keep track of the fact you pressed escape, or you at least triggered the command for escape, and that means I need to go ahead and dismiss my IntelliSense session. Now, the controller for quick info, for example, is kind of interesting, right? So quick info comes up anytime I hover over some text. And so the controller for quick info would actually be something called a mouse processor. What it's going to do is listen to mouse events. It's going to see when you're hovering over the text. And then it's going to start a session whenever it thinks you're hovering, right? So it's simple as that. And then it would dismiss that session when you're no longer hovering over something it cares about. We talked a little bit about completion already, but there's a picture of it. All right, so now the source, right? I said it was the data. So you can think of it in terms of statement completion. It would be the list of possible completions, right? That's your data in that scenario. For quick info, it would be basically the content of a tooltip, right? And that's what you see here. So you could think of basically the text that you see here being the content. And now what's interesting, so with the controller, there are cases like IntelliSense where you're going to have to implement that yourself, okay? And the reason is it's very language specific, right? With quick info, the controller, it's kind of the same across all the languages. But the one thing you're always going to have to provide to get an IntelliSense experience is a source. You're always going to need to provide some form of data, right? And so the source is one of the things we're going to look at all throughout. The last bit is the presenter, right? And I said this was the view. It's the UI piece here. Now, you never have to actually do this. You never have to give us a new presenter. And the reason is we already have presenters, right? We have the default presenters that you use all the time. So the only reason why you would want to do this necessarily is because you want to make ours better or you want to change it in some way. And I showed an example of this yesterday in my other talk, right? Towards the end, I showed a series of examples, and one of them was actually replacing the statement completion UI to add a little bit more interactivity to it. And so you certainly can do this, but you never have to. And so you can think of the UI in this case, right, in Quick Info's case, as being the tooltip itself. Not necessarily what goes into the tooltip, but the fact that there is a tooltip. And we'll look at exactly how you get information in there, because our first example is actually going to be Quick Info. And so let's think about what this is in terms of our OOC language service, right? And so what I was thinking is, when you hover over the word ook exclamation, or excuse me, the token ook exclamation point, what you'll get is a tooltip. You'll get a quick info saying exclaimed ook. Simple enough, right? And you remember I said, in general, right, we never have to really worry about the presenter. The session is just state, it's context. It's not something that we ever implement. And the controller here I mentioned, well, it's kind of the same across all languages unless for some reason you wanted to add functionality to it. And in the RTM release of Visual Studio, we're going to provide a default controller that you'll be able to use. For Beta 2, we're going to release a sample one that's virtually identical to that. So we're not really going to look at the controller because it's pretty simple, and again, you probably never have to write it. So in our terms, for quick info, the source is what's important to us, right? All we need to do is be able to provide out the data. But there are a couple of concepts you need to understand in order to do this, and these apply in general to IntelliSense. So you've noticed in some of our other APIs that we're constantly working with spans, right? We're dealing with text, and so it's useful to talk about ranges of text. But in IntelliSense case, we don't necessarily know what range of text we want to talk about. And so instead of thinking about IntelliSense in terms of spans, what you end up generally thinking of IntelliSense is points, right? So when I hover in Quick Info's case, right, all I know is the point over which I hovered. We don't necessarily know whether or not the text underneath it is meaningful in any way. And so everything in IntelliSense has this notion of a trigger point associated to it. And it's an object that lives inside of the session, inside of that context. But there's also this notion as well that when I hover over like a method name in C#, right, I don't expect as I move across that word for that tooltip to constantly go in and out, for sessions to constantly be created and then dismissed and created and dismissed. So there is kind of this notion of a span there, right, that there's a span that our quick info should apply to, and that's called the applicable to span. So in our case, right, in our example, our applicable to span is going to be the span that has the word ook exclamation point in it. And the last bit that we need to understand about sources specifically, right, is the notion of what we return. And now this is kind of interesting. We're not returning back some special type. We're not returning back something called a quick info, I don't know, item, if you will. We're turning back a list of object. Now, what's interesting here about this is the fact that we're using WPF to make this wonderful for us, right? And by returning back a list of object, what we can do is return back a string, which is often what we do inside of Visual Studio, right? All you ever see in that tooltip is a string. But at the same time, because we are using WPF and we use this construct, what you can do is return back XAML code. You could actually return back WPF code. And what that means is you have the full ability of WPF in your tooltips. So you could start putting images in there. You could really go crazy, put a video in there. Not suggested, by the way, but you can do it if you wanted to. And so that gives you a lot of flexibility in terms of what your quick info is able to provide out to people. So this is our scenario. Let's go ahead and see the code that makes this work. Right? Let's take a look at the ook quick info source. Let's close down our experimental instance there. And we have our ook quick info source. So let me uncomment these. So you can see here, in order to get a quick info source, you're, again, using our standard pattern of this provider notion, right? You're exporting out an iQuickInfo source provider. And we've associated it with the content type of ook, like we did with all of our other extensions. We've also given it a name because these are potentially orderable. Okay, so we've said we're the ook quick info source. Now you can see, no surprise here. Remember I mentioned that those token tags are going to be very useful for us, right? What we're really trying to do is basically find out what token we're over, right? And so our tagger is going to help us out a lot there. And so you can see we're implementing an iQuickInfo source. And for this class, the only method you really need to be worried about is this getTooltip content. And remember I mentioned before as well that the session constantly is getting passed around to you, right? So you always have that context for you. And I also mentioned that we have an applicable to span. Oops, excuse me. We have an applicable to span right here. Right, and so it's expecting us to go ahead and provide that so it knows how to deal with it. So it comes as no surprise. I mentioned that we have this trigger point, and I said that it came from the session, right? So there's this method on the session called getTriggerPoint. And we use that, and you can see here what we do, since we have a point, right? But when we deal with our tagger, it's expecting a span. We just create a span, a snapshot span, basically, that is a point location. It has a start and end point at the same location. And that's actually, if you remember, I said we had to look at whole lines. If we didn't look at the whole line, we would never get any tags back because that span would never contain an entire token itself. So that's a little bit about why we actually went and tried to do that. And after we get our tags, we're not doing anything crazy, right? All we're doing is check to see if it's an ook exclamation tag. Simple enough. We then go ahead and create our applicable to span, right, which is going to be the span, the span that has that token in it, right? And that's basically already, our tag has already done that for us. And then you can see we add to our content, right, our content list for exclaimed ook. So if we build this, and we run it, we should see that by exporting that out, we will now have quick info on our ook language service. So if I hover over this, you can see, right, tooltip pops up like we would expect. If I move over it, it's not constantly flashing, right? It's not going away and coming back. That's because we've got our applicable to span correct. And so that's all we needed to do to get quick info, right? But quick info is probably, and the reason we started with it, was probably the simplest form of IntelliSense. In general, right, the controller is very simple. It's only ever listening to mouse hover events. And you're just supplying back a relatively simple concept of data. So let's talk about something a little bit better. Right? Completion, the big one, the one that everyone wants for their language because it helps us be much more efficient at coding. And so we could imagine in our language, since everything is separated by a space, that what we would want to do is bring up completion when we type a space. Simple enough. Now, our completion list is only ever going to have 3 things in it, right? Because there's only 3 things in our language. So let's talk about what the source for completion might look like. So we have this notion of trigger point again, but instead of thinking about it as where the mouse is hovering, our trigger point is where the caret is, basically, right? Where we're inserting text. We also have a notion of applicable to span. But unlike in quick info, instead of thinking about the applicable to span as the span over which this should exist, right? Over which our completion UI should be presented. Instead, think of it as, what am I going to replace when I actually commit my completion, right? When I actually say, I want this, I press tab or whatever the case may be, and I want to replace whatever I've written. So the applicable to span is basically saying, I'm going to replace whatever text I've typed, this span of text, right, with whatever my completion insertion text is. And instead of returning back a list of object, what we actually return back is this thing called a read-only collection, which is basically just a list, right, of completion set. Now, something kind of weird right here is, what exactly is a completion set? Well, if we think about Visual Basic, and we remember, okay, and this existed in 2008, right, it has these tabs down here at the bottom. Now, you couldn't get this as an extender inside of 2008, but with 2010, you now can. And what you can think about a completion set is basically a new tab in this UI here. So one completion set has the name of all, and another completion set has the name common. And so you have the ability to go ahead and do this same thing. And so a completion set is basically just a list of completions itself. Let's look at what our completion source might look like. All right. so we have our completion source. Now, just like our quick info source, right? We have this iCompletion source provider that's associated to our content type of OOC, has a name so that we can order it if we need to. Now you can see we didn't create our iBuffer, or we didn't import our iBuffer tag aggregator factory service because tokens in this sense are not actually important to us, right? All we're trying to do is create new things, not necessarily deal with other ones. And the only method, again, we tried to make this so that you're only ever focused at one point, right, when you're dealing with this stuff. The method you need to worry about is get completion information. And it comes as no surprise. We're given a session like we are in all the other IntelliSense scenarios, right here. And I mentioned that our list of completions is only ever going to have 3 things in it. So I'm going to go ahead and build that list out for you. We get our trigger point so we know what location we're dealing with. And so remember I said that the applicable to span, in our case, meant the text that you expect to be replaced, right? So if I start typing 00, we expect that to go away and for the whole token OOC to go in its place. And so because our language is nice and simple, what we can do is basically look back for the first space character, and everything up until that space character is what we're going to replace, right? And so that's what this logic right here is doing. It's just going character by character and checking them. And then we create that applicable to span. And then we return back, or we create, we create our completion set and just return that back. So again, relatively simple. Again, all we're dealing with is this data, right? But if we built this right now, nothing would actually happen. And the reason is we don't have anything that is triggering our sessions, right? Now, I mentioned that in IntelliSense's case, you do have to implement a controller because that functionality that triggers a session is so specific to a language. Right? So in C#, it means something very different than it may in VB. Or if you go, the complete opposite direction, what triggers IntelliSense in Lisp would be very different than what triggers it in C++. And so we have to talk about how we would build a controller here. Well, remember our scenario, right? We type a space, and we expect completion to come up. So what we really need to be able to do is listen to typing events. But actually, we need to listen to commands, not just what's getting inserted, but we need to listen to commands. And the reason we need to listen to commands is because there are things, shortcut keys like Control-J, right, which in any language will pop up IntelliSense no matter where you are, or will pop up completion no matter where you are. So we need to listen to commands. And in order to do that, your controller is going to basically be a command filter. Now, command filters haven't changed since 2008, and for those of you who have never used one, it's essentially an object that you create that goes inside of the command chain and handles commands as they come up and passes on the results and so on. There's tons of documentation about command filters out there because they've been around for so long. And so we're not going to talk necessarily a lot about the specifics of implementing that, but we are going to talk about what that looks like for dealing with our completion, right? And if you remember, I said the controller is the trigger of the session, right? This notion of a session. But we need to be able to create that session. And so a command filter is not a special thing for us, right? It's not something specific to the editor. And so the question comes up, well, how do I go about actually creating sessions? And in order to do that, use this thing called an iCompletion broker. And basically, it's an object that you import, and all it does is gives you the ability to go ahead and create sessions as you need them. And you'll see, we'll see exactly how that works in a second. Now, once we have a session, right, the controller needs to worry about 3 concepts. It needs to know when to start it, right? And so if we think about this in completion's case, it's when to bring up that completion UI. We need to commit it, right, which is if I say, yes, I press tab, and we want to go ahead and replace, right? We want to go ahead and commit that session, make the completion happen. And then there's this notion of we need to be able to dismiss the session. We need to be able to get rid of it when we no longer need it. Otherwise, we would leak them out all over the place. And so let's look at how our completion controller is put together for OOC. Most useful language ever, I would like to point out. All right. So we have our IntelliSense controller here. Let me expand all of these. All right, whoops. Sorry, I'm looking at the wrong one. That would be the one for quick info. All right, here's the completion controller that we have. And so we're exporting out something called an IVS text view creation listener. And this basically makes it really easy to get a hold of IVS text views, this old object, right? And that's how you add command filters. And then remember I mentioned that we're going to need to import an iCompletion broker. This is what gives us the ability to create sessions. And so again, this is the standard. You're creating a command filter, right? An IOLA command target. And there's a bunch of documentation about how to do that. But you can see this is kind of what I want to look at right here, right? This notion of, okay, so we're listening to these commands, things like autocomplete, right? Complete word, the return key, the tab key. We're listening to these to go ahead and fire off the events we expect to happen within our session. And so let's go down. Also, we're listening to type char, right? So we need to be able to handle when a space is typed. But let's go look at what these functions look like things like start session in this case. So we see down here at start session, remember I mentioned that we need to have a trigger point, right? And I said, well, in general, in completion's case, that trigger point is always where the caret is. And so this line of code that we're looking at right here basically goes ahead and gets that caret position for us. And then we use our broker, right, to create a completion session for us. And we give it a text view because your completion session is going to be specific to whatever view, right? So imagine if I split this view in half right now, and we had, and I brought up IntelliSense in the top half. We wouldn't expect the bottom half to also pop up IntelliSense, right? So that's specific to each view. We go ahead and give us our trigger point, right, which is where our caret location is. And then we just call session start, right? So we've gone ahead and said, we're now in a completion session. And what that is going to do is filter down and go ahead and pop up that UI that we expect to see. Then we also have logic for when we want to complete, right? So if the completion list is up, if a session is up, and we press tab or return, we want to go ahead and commit that session. And remember I said committing is basically saying replace whatever text we've typed in that applicable to span with our insertion text in our completion. And you can also see that we dismiss the session whenever you press escape or whenever there's no valid completion here. And so if we build this now, we have a source, we have a controller. We should now see, as we run this, that we'll actually get completion as we would expect to when I type a space, for example. So let's open up our ook file here. If I type space, there you go. We have completion, right? And then, like I said, we're only ever going to have 3 things in our list. But at the same time, so if I start typing, you can see we activate it. If I press that, it replaces the O, right? So we got our applicable to span correct. If I start typing a bunch of things, what it would do if we said replace it with this is replace all of that, right? Because of the way we did our applicable to span. So there you go. That's completion, basically. Now, the main thing you have to remember about it is this notion that we have a controller, and that controller in Visual Studio's case is pretty much always going to be a command filter. You have to listen to those commands, like typing commands and then things like pressing tab and return. And we also had that source, right, telling us exactly what to pop up in our UI. Now, we picked a language, ook, right, which is very, very, very simple. And so some of this might seem like we just looked at a toy, right? This isn't real implementation. But a lot of what we saw today is based on the actual implementations inside of Visual Studio. So what I showed you today is not a toy. It is not something that you can just you can think of as a throwaway. It actually is legitimately how we do these things inside of Visual Studio. And so I just wanted to dispel that because I picked an esoteric language that this isn't important. So let's talk a little bit about all the things we've gone through, right? We learned quite a bit in this one. We started out talking a little bit about the fact that if you're on the managed language service, if you're working against the old COM APIs, you should be able to continue to use those for Visual Studio 2010. We then talked about how content type is the key to everything, right? Without a content type, you don't exist inside of Visual Studio. And so if you want to get a language, right, you have to think about creating that bucket. And you can also think of content type, remember I said, you can think of it as a hierarchy. And placing your language underneath code is generally what we're telling people to do. We talked about the fact that tagging is everywhere, right? We created that general purpose tagging, and because it is everywhere, we were able to use it in a bunch of places, right? So we learned that classifications are themselves tags, and we were able to write a tagger for that. We learned that errors are tags. We learned that outlining is tags, right? And so you can do all of these things using this nice, simple mechanism. Then we talked a little bit about IntelliSense, and how when we talk about IntelliSense, we're actually talking about these things, right? We're talking about quick info, we're talking about smart tags, statement completion, and parameter help. We mentioned the fact that all of these things share basically the same architecture, right? We talked about how it's MVC, how you have a source which provides out this data, right? In completion's case, the completion list. You have a controller which pops up and creates, which creates sessions, right? And those sessions are what go ahead and pop up the presenter, the UI. But there are two things I want to leave you with. And the first one is this. So you saw when we worked on our language here, right, we created that general purpose tagger. And there's this notion that since this is a bucket that other people can start working on, so let's say you think you're done with your language integration, you've got all of these things, but people will still want to add functionality to your language, right? They're still going to want things that you haven't thought of yet. And so if you provide them with the tools to do this, things like the general purpose tagger, you're enabling them to go ahead and understand your language, right? Because you've already done that work. There's no reason for them to go do that. You're giving them the tool basically to create extensions on top of it, right? So consider lending tools to your neighbor. Consider doing this thing like a general purpose tagger. And the other thing is we want you guys to go out and try this stuff. A lot of this is brand new, right? A lot of this stuff is sort of conceptually a little bit different than what it was before. And we're still trying to make sure that we've got it better. We're trying to make sure that we have a picture of what this is going to look like in the wild. So we need to know, we need your feedback to know how to make it better, right? What we need to improve, where some of our gaps are. And as always, right, I say there's always so much more to learn. And in this case, right, we only talked about a few of the things on the list. So go ahead, check out our blog. There's going to be more information up there. And again, my name is Chris Granger. I will, in general, be your contact for editor extensibility. And let's open it up to questions. Yes, sir.
For those of us who have an existing language service, I'm going to be replacing one little bit at a time with the new stuff as I go through it.
Yep.
We've already got our own editor factory and all that works fine. Does that automatically come up with a content type? I kind of remember asking the question before, and that's what it.
Sure.
That when I have I've got an editor associated with my language, and my language is registered in all the proper places. Is it automatically a content type for my language, so I can just put that into my extensions, or do I need to do an additional step? Yeah, no.
So the question is whether or not, okay, so I've implemented against the older APIs in some form or fashion, and he's asking, well, if I have a language service, do I already get a content type, right? If I have this old style language service. And the answer is yes, you do already get a content type, so you don't need to create another one. You're able to go ahead and start writing extensions against that. And one of you editor devs, exactly where does that name come from? So it comes from the registry, whatever you name your language service. So it comes from whatever you register in the registry. Yes, ma'am.
So if I want to extend one of the existing content types, where do I find the name of, say, the C# content type or the Visual Basic content type or this content type?
I see. So the question is, how do I find out the name of the content type so I can write extensions against it, right? So one of the things that we're going to do is obviously document all of our content types. So C# is literally C#. If we go back and look at this for a second, let's see here. Yeah, so it's C#. Visual Basic is basic. Does anyone know what C++ is? Is it C, literally C++? Yeah, okay, literally the character plus. And so we'll document those. Now, in terms of knowing what his content type is, that you're going to have to work with other people a bit about to understand.
There is also the content type registry is queryable at runtime.
Oh, there you go.
You could write an extension that just looks over all the content types that are there. See what there might not be one, but you can pull it.
Is there a what? Sorry.
Makefile content type.
Not that I know of, yeah. Yeah. No, so the question was there a makefile content type, and not that we're aware of. Okay. Oh, yeah. So what Noah was saying is that in order to find out what content types that are inside of Visual Studio, you can actually query the content type registry service at runtime to find out that information and expose it. Yeah, go ahead.
Do you have any support for writing a parser for another language?
For writing a parser for another language? No. In general, all we're talking about here is the editor specifics, right? And we worried about going that direction of providing something that was itself a parser because technically speaking, that has nothing to do with us, right? And we were worried about having to deal with making sure that we got that right and supporting it throughout the lifetime. Just a token parser. Well, you saw, we basically wrote one, right? That little bit of code is all. Yeah.
You'll have to write one. So.
Yes. Yeah. You will have to write a token. Yeah.
You mentioned that we should land tools for our neighbors. What kind of tools do you land for us to handle Visual Basic and C#?
I see. So regrettably, we didn't get the chance to do a lot of this ourselves because of tagging came relatively late in our cycle. And so what you're going to have to do, and I mentioned this yesterday, which is not necessarily exactly what we want, you're going to have to start looking at things like classification type tags to understand, or excuse me, classification tags to understand, some aspects of C#, for example. So if you want to be able to look inside of comments for a certain thing, you would go ahead and create a tag aggregator for classification tag and go that way about it. But that's something we're definitely going to look into improving on vNext. Other questions?
So
Yeah.
the previous support in 2008, I think for the Yak and Bison file, those translators are still working for 2010, right?
Yeah, so the question is, so we used to have a thing called manage Babel, right? And that's basically took something that's the equivalent of a Yak and a Lex file and turned all of that into a language service. That's the managed language service stuff, and yes, that still works. That, again, is just a matter of basically recompiling against Dev 10. Any other questions? Yep.
Yeah. Are there plans to support a Babel-like system on top of this in the future?
Right now, no. Right now, no. So one of the things we do know is that not everyone wants to go out and write a compiler. And so we're going to look at how we might handle that situation in the future. But right now, we don't have any definite plans. Others? Yeah. Sorry? Sorry. MBD? Oh, embedded languages. Sorry. Okay, yeah. So the question is, how do you support embedded languages? So we support this using something called projection. And what projection enables you to do, basically, is say that a part of the visual buffer, so the buffer that you see at the top, is actually constructed of many buffers down at the bottom level. And so you're able to say, well, okay, so one of these buffers is going to be HTML, right? So the common embedded language scenario is in web development. So one of these buffers is going to be HTML. And if we think about ASP, right, so one of these other buffers is going to be C#. And so you basically break your file down into buffers based on each type of content. That can get really complicated the more buffers you have and all the different scenarios you have to deal with, right? Like knowing when you're on the edges and so on and so forth. If you want to work with some of that stuff, you want to get a hold of us right now. We don't have a lot of documentation on it, but that's something we're definitely going to be improving on going forward. Any other questions? All right, well, thank you, everyone. Go enjoy the rest of your day.